Hello, algebra students. I hope that everybody is doing well. We are in chapter 8 now, and this is section 8-1, day 1. We're talking about polynomials in this chapter. And so what I'd like for you to be able to do by the end of this lesson is to identify and classify polynomials in multiple ways, and I'd also like for you to be able to add polynomials together. So let's just jump in with some vocabulary because we've got some words that you might not be familiar with. So first of all, monomial. So a monomial is a real number, a variable, or a product of a real number and one or more variables. So a monomial does not have any addition or subtraction. So you can have multiples, that's what product means, and you can have lots of variables and really any number. You just cannot have addition or subtraction in your monomial. So some examples of a monomial might be 5.8 or negative 2xy. Notice how there's no addition or subtraction. That's a negative sign, but that's not addition or subtraction. We could also have division. So we could have 6x over y squared like that. That also works. All of these are considered monomials. Now, there's lots of ways that we can describe monomials, and in one way is by the degree. So the degree of a monomial is the sum of the exponents of its variables. So the sum of the exponents of the variables, that's the important part of that. And let's say that you just have a regular number. Well, if it's just a plain number or a coefficient, it is going to have a degree of 0. So let's just look at that in action in this next example so we can talk about the degree of these monomials. So in example A, you have 5x. Now, I'm not going to count the coefficient on the 5. I'm only looking at, the exponent. I'm not going to look at the exponent on the 5. I'm only worried about exponents on variables. So if there's an invisible exponent on this x, then it has an exponent of 1, which means the degree of this is 1. Because my question is, what is the degree of each monomial? In example B, I have 6x cubed. I'm not worried about the exponent on the 6 because 6 is a number. I'm only looking at exponents on variables because notice it says the degree of a monomial is the sum of the exponents of its variables. That's important right there. So x cubed, the exponent is 3, so it has a degree of 3. 11 is just a plain number. It does not have any variables. So I'm going to say that it has a degree of 0. And then here I have 8x squared y cubed. In this case, I have multiple variables and each have a different exponent. You are going to add the exponents up in this situation. So this is going to be 1, 2, 3, 4, 5. It's going to have a degree of 5. All righty. Now with monomials, we can do lots of stuff, and one thing that we can do with them is add them. So when we add and subtract monomials, it is just like adding or subtracting like terms. But the big thing that you need to remember is like terms have to have the exact same variables with the exact same exponents. We cannot have different exponents or different letters. So let's look at these next examples where we are just going to add like terms. So I have 3x squared plus 5x squared. I'm going to say 3 plus 5 because I'm adding the coefficients, and that's going to get me 8. The x squared and the x squared is going to stay the same. Because of our previous unit, I can see people accidentally turning this into x to the 4th. It is not x to the 4th because you only add exponents when you're multiplying. But we're not multiplying in this example, we're adding. So because we're adding, we're keeping the variable matching. Looking at example A, it says 4x cubed y minus x cubed y. If you need to put in that invisible 1, then you can. That's no big deal. So now I have 4x cubed y minus 1x cubed y. Well, take your coefficients, the 4 and the 1, and subtract them. So 4 minus 1 is 3. And then I'm keeping x cubed y the same. So x cubed y. In example B, I have negative 6x to the fourth plus 11x to the fourth. All right, I have a negative 6 plus 11. So that's going to become positive 5. And then the x to the fourth is staying the same. Once again, this will not become x to the eighth. It is not x to the eighth. And that's because I am adding the two expressions. If I were to multiply them, that's when the exponents will change around. But when I'm adding like terms, the variables stay the same. So finally, in example C, I have 4x squared y to the fourth minus 7x squared y to the fourth. Take your coefficients, the 4 and the minus 7, and do that operation. So 4 minus 7 is negative 3. And then carry down your variables, x squared y to the fourth. So this is very similar to what we've already done. This is just, adding like terms. Okay. Let's get into something a little more advanced. What is a polynomial? So a polynomial is a monomial or a sum or difference of monomials. In other words, a polynomial is when you add and subtract individual monomials all in one expression. It is multiple terms, poly meaning many. Okay, so on the back side of our notes, it says, when writing a polynomial, often it is written in standard form. The standard form of a polynomial means that the degrees of its monomial terms decrease from left to right. In other words, put the big exponents first and put the small exponents last. The degree of a polynomial in one variable is the value of the largest exponent. So you are going to see that here in just a moment. We have this table just for you to reference. These are all examples of polynomials. And if you want to describe it by its degree, you're going to look for the biggest exponent. This is just a plain number. So it is not going to have a degree because it does not have a variable to have an exponent on it. Here I have 5x plus 9. It has a degree of 1 because the exponent on this x is a 1. This guy has a degree of 2 because the biggest exponent is 2. This example has a degree of 3 because the biggest exponent is 3. And this one has the biggest exponent as a 4, so it has a degree of 4. So the degree is talking about the biggest exponent. So I'll put that there, biggest exponent value. Now, as far as naming something by the terms that it has, this is how many pieces it has, for lack of a better term. So this guy has 1 piece, this guy has 2 pieces, this guy has 3 pieces, or how many monomials are in it? This one has 3 pieces. The pieces are separated by addition and subtraction. So we would call monomial a 1 term, binomial, bi meaning 2 terms, trinomial, 3 terms. So let's put that into action in example 3. In example 3, it says, write each polynomial in standard form. What is the name of the polynomial based on its degree and number of terms? When we put something in standard form, we want it to have the largest exponent first and then the smallest exponents last. So in this one, 4x squared has the larger exponent, so I want to write it first. And 3x has the second smallest exponent, so I'm going to say plus 3x. This is now in standard form. But if I were to name this based off of its properties, I would say that it's a binomial. And I would also say that it has a degree of 2. In other words, the fancy word for that is quadratic. Binomial because there's 2 terms, degree of 2 because the biggest exponent is a 2. Let's look at example B now. We have 4x minus 1 plus 5x cubed plus 7x. So in this example, I want to simplify this before I rearrange it. Hopefully you can see that we have 4x and 7x that can be combined. So let's combine those and then carry anything else down. So 4x plus 7x is 11x. And then I've still got minus 1 and I still have plus 5x cubed. Now it's time for me to put this in standard form. So you're going to put the term with the largest exponent first and then go down in descending order. So I have 5x cubed plus 11x minus 1. Notice the exponents on the variable are decreasing from left to right. So this is going to be my final expression answer there. Now, if I were to describe this based off of its degree as well as its amount of terms, it is a trinomial because it has 3 terms, and it has a degree of 3 because the largest exponent is a 3. In other words, that is a cubic in fancy. Now, something that we're going to be doing a lot of is adding polynomials. So when we add polynomials, we are going to be adding like terms. And if we're able to in these examples, we want to put these in standard form. So we're going to add the polynomials by adding like terms. Don't let the parentheses throw you off. If you want to think about it this way, these parentheses are distributing a positive 1 because there is a positive 1 in front of both of those guys. So if I were to distribute a 1 to both sets of the parentheses to get rid of them, no value is truly going to change. So I'm going to have 5x plus 4x squared plus 2x squared plus 9x. Now I'm able to combine like terms. So I can combine positive 4x squared with positive 2x squared. I'm not allowed to combine it with the 5x or the 9x because they don't have matching exponents. Remember, like terms are going to have matching exponents and matching variables. So 4x squared plus 2x squared is 6x squared. And then 5x plus 9x is plus 14x. And there's our solution in descending order already for us. In this next example, there's still an invisible 1 in front of this parenthesis, and there's still an invisible 1 in front of this parenthesis. So if I need to write them in and distribute, then I absolutely can. And that's how you're going to get rid of the parentheses to work around them. So this is becoming negative 5x squared plus 8x cubed plus 3x plus negative 18x minus 3x squared minus 4x squared. And now we want to start organizing this, combining it, and getting it into standard form. So I'm going to start with the 8x cubed because that's the largest exponent. So I have 8x cubed right here, and I cannot combine it with anything. So I'm just going to go ahead and carry that down. I've got 8x cubed. And then I'm going to look for my next largest coefficient, or I mean exponent, which is squared. So I have negative 5x squared minus 3x squared minus 4x squared. Well, when I combine all of those, I'm going to get minus 12x squared. I'm keeping the x squared because all I'm doing is combining like terms and I'm not multiplying. So the variables and the exponents stay the same when adding and subtracting. And finally, I have positive 3x and negative 18x. So when I add those up, I should be getting negative 15x. This is in descending order because this exponent is 3, this exponent is 2, and this exponent is 1. So notice 3, 2, 1. It's going down in value. We are good to go. So let's keep combining like terms in examples C, D, and E. So I know that the parentheses are just going to go away since I'm distributing that positive 1. So I'm going to rewrite it. I got 5x plus 6xy minus 2y plus 7xy minus 2x minus 4y. Alrighty, combine like terms. I'm going to start with the xy first, I think. So I've got positive 6xy and positive 7xy. 6 plus 7 is 13. and then I'm still carrying the xy over. Just because it's two letters doesn't mean you're going to treat it any differently. If it has the same variables with the same exponents, then you are good to go. Okay, next, I'm going to go to the x's. So the x's are negative 2x and positive 5x. So when I combine those, I'm going to get plus 3x. And then finally for my y's, I have negative 2y and negative 4y. Combine them, I get negative 6y. In example D, I'm going to rewrite it without parentheses just so you can see it that way. Once again, if there's nothing in front of the parentheses, that's an invisible 1, and if you distribute the 1, then you can get rid of your parentheses. So I've got 2x squared y plus 3x cubed minus 2y plus 5x cubed plus 3y squared x plus 4x squared y plus 2y. Whew, what a mouthful. What I'm going to go ahead and do, just because I noticed this, I have a negative 2y and a positive 2y, and those are just going to totally cancel each other out. So I'm going to mark them out so I don't have to think about them anymore. Now I'm going to look for something that I'm able to combine. Here I have a positive 3x cubed and a positive 5x cubed. So I'm going to combine those to get me 8x cubed. Because 3 plus 5 is 8, and then I'm keeping the x cubed the same. Then I have 2x squared y and plus 4x squared y. I'm combining them once again, so 2 plus 4 is 6, so I got plus 6, and then I'm keeping the x squared y the same. I have one more term right here, plus 3y squared x, but it doesn't have anything it can be combined with, so just carry it down. So plus 3y squared x. We have one more example, example E. So here, I'm just going to combine like terms without getting rid of parentheses. If I'm looking at my x's, I have 3x plus 3x, which will get me 6x. And then if I look at my y's, I have negative 4y and negative 3y, which will get me negative 7y. And then finally, positive 2 and negative 7, which is minus 5. And that's everything that we have for adding and subtracting polynomials for today. I hope you have a good night.